speaker today is a longtime member and a longtime woodworker, Ben Blackwell. Ben moved to Albuquerque, the first of 3 times, in 1965, when he accepted an engineering position at Sandia Labs. His entire career was spent at Sandia Labs, with the exception of a 2-year stint from 97 to 99, where he taught mechanical engineering. His work at Sandia Labs involved thermal testing and developing software to model thermal phenomena. After retiring in 2004, more time has been spent on his working while continuing to consult at Sandia about a day a week. He had been fully retired since 2015. His woodworking interests include fine furniture making, jigs, fixtures, and using SketchUp. He's kind of our SketchUp guru, expert, to model various projects. Ben is in the middle of getting a new shop up and running. The biggest project of late is a dedicated dust collection system. His topic today is outfeed table. An outfeed table for table saw increases its functionality as well as its safety. The ripping of sheet goods, long boards, can be accomplished much more easily and safely. The outfeed table can also be used as an additional work surface. You can never have too much horizontal workspace. This talk will focus on the design and construction of an outfeed table. Design requirements will be presented along with SketchUp models of the outfeed table. Emphasis will be on using good quality furniture-style joinery. The jigs necessary to make the mortises for floating tenons will be discussed. So I think we're in for a treat, and with that, we'll have our expert present, Mr. Ben Blackwell. Thank you, Ben.
Thank all of you for coming out, especially after getting here and realizing that the donuts weren't here.
Come on, Ben. Thanks for not leaving.
Yeah, I'm surprised they didn't leave. So hopefully your stay will be worthwhile. I've taken a number of classes at Santa Fe Community College. You kind of get spoiled taking classes up there because the shop is really first class, and you think, gee, I'd really like to have all that at my house. Well, building an outfeed table is one of those steps in that direction. So from a safety perspective, you want to keep your hands behind that saw blade. And I suspect I've managed to reach behind that saw blade on a few occasions where I had a long board and something kind of iffy was happening, and so far I've still got all 10 of them, but hopefully by having a dedicated outfeed table I can practice a little bit better safety. Within the past year my shop space has grown, and I now have the luxury of having room for a dedicated outfeed table. For many years, I just had a table saw and had to make do with that. And I've put together some sort of, pardon my French, but half-assed outfeed tables that you clamp a board on top of a board, and even bought roller stands, and then they tip over. So I'm really enjoying having an outfeed table. Of course, I'm probably the only one that's ever had a roller stand tip over on. Well, the next slide shows the finished product. And that's as pristine as you're going to get to see it, because my comment about never having enough horizontal work surfaces, my shop, every surface has got something cluttered on it until I just can't stand it anymore, and then I clean house. So let's talk a little bit about the design process and the requirements that I put together to come up with an acceptable design for my outfeed table. I want it to be large enough to accommodate sheet goods, both 4x8 and 5x5 sheets of plywood. It needs to be stiff enough to serve as a work table because I want to be able to clamp things to it. So you need an adequate overhang so that you can apply clamps to it. Needed a relatively smooth surface so your stuff coming off the table saw moves freely and you're trying to reduce the friction. You need a surface that doesn't allow glue to accumulate there, and so you want to be able to scrape the glue off easily. I wanted to use mortise and tenon joinery. Those of you that know Joe and I know that we don't need any more furniture. So I like to use good quality furniture construction techniques, but I'm sort of out of business making any more furniture for the house unless I give it away to family. Needed storage underneath the top. I needed to be able to partially disassemble this because if you get a table that's will handle a 4x8 sheet of plywood, it might be kind of hard getting it out of the door. And so I wanted to be able to partially disassemble it. I thought I wanted levelers on each leg, which I did. But I also found a design on the internet in which somebody had a casters and a lift mechanism that was an integral part of a workbench that they built. And I thought it was a pretty ingenious design, and my original idea was to implement that on my work surface or outfeed table. But eventually I realized that that really wasn't going to be very practical given the square footage that I have in my shop. In order to move the outfeed table somewhere else means I'm going to have to rearrange all the chairs on the, so to speak. And so eventually I abandoned the great mobility for an outfeed table. And it's permanently attached to my table saw. And you need to have room between the outfeed table because in my case, the outlet for dust collection is on the back side of the table saw. So if you ended up with the legs being right up against the back of the table saw, then you wouldn't be able to put dust collection connections in place. So based on that list of requirements, here are some of the design features that I settled on. So the top is roughly 48 inches by 48 inches. I had 2 layers on the top, 3/4 inch melamine over 3/4 inch MDF. Turns out I had partial sheets of MDF and melamine, and I fortuitously was able to make use of that. It hadn't warped sufficiently because it was leaned up against the wall, and it was still pretty flat. So I got leg levelers from a company, AWA20180310. Actually, it came from Amazon, but that's who Amazon got them from. And then a brad hole T-nut to accept the leg levelers. I tried to use trestle table construction like the workbench that they build in the workbench building class at Santa Fe Community College. I took that class in the summer of a number of years ago, in which everybody in the class built a workbench, and I would highly recommend that if you think you want a really good quality workbench. And so everybody in the class came home with a workbench. So I picked 1.25 inch thick poplar stretchers and 2.5 by 2.5 inch poplar legs for the major structural members. Since it's going to serve as a work table in addition to an outfeed table, I felt like I wanted it to be Helfer stout. So this is some of the other factors that influence my design. I spent a lot of time talking with Tracy and looking at his outfeed table to get an idea of what the footprint should be in order for it to be workable. And then the joinery was very similar to what was on my Santa Fe Community College workbench. And then this is a picture. It's actually a SketchUp drawing I got from the internet. A guy named Bill Farrier is the one that designed this workbench with a lift mechanism. And you can see here, you stand down on this lever that you pull down, lifts it up off the floor. And it really seemed like a neat idea, but it just wasn't going to be practical for mine. So prior to the detailed design, you want to purchase all the hardware. I've learned by experience that sometimes you're building something and you think, well, I'll buy those hinges later on. Wrong. That's the wrong approach. So any hardware that's part of your project, you need to buy that up front, because you don't get to change that unless you throw it in the trash can and go and buy something different. So I bought the leg levelers. I ended up not using casters, but that's just an example of what you would do. Any nuts and bolts, anything that you don't have control of over the design, buy that up front. Well, as many of you know, I like doing things with SketchUp. So one of the first things I did was take my conceptual ideas and turn that into a SketchUp drawing. The design uses what's called a trestle end. And do we have a laser pointer, or do I just use my finger here?
We'll have to get it out of the case.
Okay, no, that's all right. I'll just use my finger here. So this assembly here is called a trestle, and there's one on each end, and so therefore it's a trestle end design. And then 2 layers on the top, and there are top and bottom stretchers on all 4 sides. And here you can see the hole for the drawbore construction that I chose to use. That was on my Santa Fe Community College workbench, and I really like that feature. That's what allows you to disassemble the trestles from the rest of it. So there's no glue outside of the trestle end, with the exception of the tenons. Yes, Rich?
And I'm not sure I quite follow. So you're saying the tenons are vertical and they go into the apron?
The tenons, there are vertical. I'll show an exploded view, and I think that'll answer. The question was about the orientation of the tenons, and I have an assembly drawing or an exploded view, and it'll show you where the tenons are placed. But there was the trestle end here and its mating member. There's glue gluing those members together, but there's no glue between this stretcher and the leg, as well as this stretcher and those 2 members that come together. And that'll be a little bit clearer on the next one. So here's the exploded view of the components. I didn't explode the trestle, and that'll be on a subsequent slide. So you can see that here are tenons. There's a double tenon here on both ends of that, single tenon here, and then there's a stretcher running across here, single tenon there. Yes.
Why do you use 2 tenons as opposed to a single tenon? What is there?
The question was why use 2 small tenons as opposed to 1 wide tenon? Tenons are cross grain, and eventually, if you make it too wide, the tenon is a wide single tenon is likely to split on you. It wants to grow, and it's confined. So there's some rules of thumb that I think they gave us at a class in Santa Fe Community College, and I don't remember what those rules of thumb were, but
You follow.
so this was wide enough to where a single tenon wouldn't have worked in that case, or might not have worked. I shouldn't say it wouldn't work, it might not have worked. Okay.
Well, one last question, which you'll get to. By gluing in the tenons on these stretchers, you're locked into this thing being together because they're glued in. But you're using dry fit draw bolts on the stretchers, which would suggest you're ready to take them apart.
Yes.
But it seems like you accomplish nothing to take them apart because you're stuck to the stretchers.
Well, the stretchers are not glued to the trestle. It's the draw bolt that holds the stretchers to the trestle.
Okay.
Draw bolt. What is a draw bolt?
Thank you for being my straight man. Shane asked, what's a draw bolt? Well, this is one of the samples that I made during the project, and you can see that there is a bolt on top, goes down through here, and there's a hole, and you can see the nut there. So you tighten up on the top bolt, and that draws these 2 members together. So there's no glue holding those 2 together, and that works great with the workbench design that I used from Santa Fe Community College, and so I figured it would work again here. So I'll pass this around, let people look at that.
If you look at the bench up here, it has
Yes, it does. These are a little bit smaller draw bolts. During the break, if you look at the legs here, you can see that that's put together with a draw bolt. So this is what the trestle looks like in an exploded view. So there's glue joining this stretcher to the leg so that now becomes a single unit.
Right.
You can take this unit apart from the rest of the table by loosening the draw bolts. So this would permit you to get it through a normal size door. In my shop, I added a 48-inch wide door, and I might be able to get this out that door without disassembling it. But if you've got a 32 or 36-inch wide door, you wouldn't get this guy out the door. It becomes a permanent fixture in the structure. So you can see that there are a lot of tenons, mortises and tenon joints in this process. Well, with the drawings completed, I was ready to start the fabrication process. I used a 6-quarter poplar, and I sort of made a mistake, or maybe it wasn't available then. I purchased all this lumber from Albuquerque Hardwood before they became part of Rugby. And so what they sold me was S3S lumber. And I don't like anybody surfacing lumber but me.
what S3S means.
Okay, surface on 3 sides is what S3S means. It's not that I'm so great at milling lumber. It's just when you've got a certain thickness requirement, if somebody else has already run 3 sides of it through a surface planer, then you've lost a lot of thickness. And when was the last time you bought a board from a lumber yard that was sufficiently straight that you could turn it into a piece of furniture right away? So it's going to warp and twist and bow, and in retrospect, I probably should have said thank you but no thanks to Albuquerque Hardwood at that time, because I've subsequently done, I'm right in the middle of another project, and I got the lumber from Rugby, and they had completely rough, and the stuff was 1.25 inches thick typically, and so I had much better success. Jim, you had a question?
Yeah, the S3S, that's top and bottom and 1 inch, right?
Yes. Rich?
So why did you have to use 1 1/4? Why not 1 1/8? 1 inch?
I didn't want to sacrifice. I didn't want to step down. Maybe some of those boards were, I can only get 1 inch thickness out of it. I decided how thick I wanted, and damn it, I was going to get it that thick.
That's the answer.
He's an engineer. Yes, sir.
The legs had to be glued up. I didn't try to get 8/4 poplar. Well, even 8/4 wouldn't have worked on this. So I had to glue up the legs to get the 2.5 by 2.5. Try to mill all your stock at the same time. And particularly when you're doing mortise and tenon joinery, you're relying on consistent thicknesses. It's not that you got to have precisely 2.5 by 2.5. You want every leg to be the same cross section, whether it's 2 3/8. That would have worked, but consistency is more important than the actual number. So if you mill up a bunch of stuff and later on you screw it up, which that's what that caveat is. It almost worked in this case. I had to go back and remill some piece, and I don't remember what that piece was at that particular point in time. So I did all of the milling, and I tried to leave or end up with some extra pieces. What being passed around for that drawbore joint was my trial to make sure that I did it right. Because even though I had a workbench from Santa Fe Community College that had that joinery, the way they construct the workbenches there, you don't build your workbench from start to scratch. It's built in a production furniture kind of environment in which you come in and the shop foreman tells you, you and this are going to be milling this particular part. So you make that piece for everybody's. And I didn't get involved in actually doing the drawbore joinery myself, and so I wanted to make a sample and make sure that worked okay.
Ben, why did you decide on poplar?
Cheap hardwood.
Cheap hardwood?
Yeah. It's one of the cheaper hardwoods. That's what they use for the workbench in Santa Fe Community College, and so I just stuck with that. If you want to get fancy, you could have made this out of oak, and it would have weighed, I don't know, 15-20% more probably. As it turns out, it's heavy enough to where I don't think it's going to get up and walk off, but
Don't they use a lot of ash in Santa Fe?
yes, for the furniture, nice furniture stuff, they use ash, and ash is certainly one of the denser woods. They encourage ash as opposed to oak. I think the instructors at Santa Fe Community College got tired of seeing oak on everything that everybody built, and so they said, okay, you're not going to use oak, you're going to use ash. At least whenever you take the wood of 111. Yes? So ash is cheaper than oak? Okay. So everybody hear the comment that ash is cheaper than oak. I have not purchased any since I took wood 111 at Santa Fe Community College, and the wood there, they purchased it for you, and all you did was pay a shop materials fee.
And may I comment on wood choices?
Yeah.
Something that's emerged in the Albuquerque market in the last 10 years, or maybe a little less, is the low price of ambrosia maple. It's a soft maple. I really like to work with it. It's running about $2 a board foot these days. So it's cheaper than poplar most times when I go shopping. And I like to work with it more. So it's something to consider.
Okay. For those that
Rugby.
You don't want to resaw it because it's often hollow in the middle.
All right, so Tracy.
Okay. So the for those of you that may not have heard, the comment was ambrosia maple is an alternate to poplar, and it's reasonably priced, $2 board foot. Tracy's comment was, watch out for the wormholes in the middle, or whatever that makes those holes. Gail?
Another name for ambrosia maple is spalted maple.
Okay.
And wormy maple. You go to the
Okay.
shop there to buy it.
But that is available locally at Rugby. So this is showing my drilling setup for the leg levelers. Unless you have a taller drill press than I do, you can't put one of these legs in and drill it. Plus, you've got the issue of getting everything vertical. So the way I drill the holes for the leg levelers, it's hard to see, but this is really a small cutoff from one of the legs. So here's the leg in the vise, and then made it longer than I needed, so I saved the cutoffs, went to the drill press, carefully drilled the hole in the center of the cutoff, clamped that cutoff onto the leg, and then this became a poor man's drill guide. And if you run into the situation, well, on the leg levelers, there's no problem getting a drill bit long enough to handle that, but that's not the case with the hole for the draw bore, and I'll talk about that a little bit later. So it's good to have excess length for little things like this. Make your own drill guide.
How far does the leveler go into the bottom of the leg?
John asked, how long does the leveler go into the leg? I don't remember specifically, but I think it's of the order of 1.5 inches. Okay. And you can, if you have specific requirements, you can shop around and probably get some either longer or shorter than that if you need that. Okay, since I chose to use floating tenons, and for those of you that may not have encountered the term floating tenon, that means that the tenons are little bitty short cutoffs from this guy. This is left over from the tenon stock. So you cut these guys to whatever length tenon you want. So you can mill and browned over the edges, put a glue slot in there, and I can pass that around. But the main thing I want to focus on here is making a jig to do all the tenons. Mortise. So to orient you in the view on the photograph, you're looking down on my router table. So that blue, and this is part of the fent, blue and this MDF here. So there's the router bit, and there's a stop on the right-hand side and a corresponding stop on the left-hand side. And so what I'm trying to do is cut this slot in here, and that's what I'm going to use to make the mortises with. So I'm sizing that to match my drill bit and the guide bushing. So I needed a mortise opening of 3/4 by 1.5. And that's not the dimensions of the slot here. The next slide shows, well, before I go there, you can see a black object on this side. That's a gauge block. I know how far the stock needs to move to accomplish the desired slot length. So you've got to worry about the fact that you're only moving it from the center line of the cutter in this position to the center line of the cutter in that position. So I've made enough mistakes doing the math associated with this that I finally got smart and tried to document that. So here's a picture that I keep around, and it's got the required math that you have to go through for a given geometry that you're trying to achieve. I knew I wanted, I was going to be using a 3/4 inch diameter router bit. This dimension here, the capital D, that's the width of the slot. And so there's an offset. There's a difference in diameter between the diameter of the cutter and the diameter of this imaginary circle here that's part of the slot. And so that offset in this case, I believe, was 1/8 of an inch. And if I don't carefully go through my notes and my pictures, I'm going to screw it up. Yes. Do you find an advantage of the floating over the fixed? I personally believe they are easier to fabricate. They are almost as strong as a regular mortise and tenon. Here, all you're doing is you're making mortises, and the tenons are an easy thing. Whereas if you take the traditional approach of either a square cross-section tenon and mating that with a mortise that was made with a router that's got round ends, and so do you square off this end of the mortise, or do you round that end of the tenon? I've done it both ways, and I think this is easier given the equipment that I have.
Now you can afford it, Tom.
No, I can't yet.
But I mean, I'm not trying to be argumentative here, but if you have to do one of the mortises in end grain, it's not really thick. That has to be done very carefully.
Yeah, all the mortises have to be done very carefully.
No, but the end grain ones, right?
Well, that's no different than if you were doing a traditional mortise and tenon joinery and you had end grain involved.
Okay. But you use the same jig for both mortises.
Yeah, I use the same jig, but I think the point that I think Rich is trying to make is that if you make a traditional tenon, you probably got more strength there, but the people that do tests on this show that there's not much difference structurally in this floating tenon approach versus the traditional mortise and tenon.
But if I have a long piece and I have to cut mortise in that end grain, right? It's long. That has to be done very carefully.
Yes, yes, yes. They all have to be done very carefully.
Another advantage of not cutting the traditional tenon is you don't have to worry about square shoulders.
Okay, the comment was, this approach, you don't have to worry about square shoulders. If you use the traditional tenon, you got to take quite a bit of care to make sure that the tenon has a square shoulder on it. Otherwise, when you put two members together like this, you're going to have a visible gap.
In the class we took from Larry Beakley, he said that the floating tenon is 93% as strong as a regular one.
Okay. The comment that Tracy made was that the floating tenon is, according to one of our instructors, Larry Beakley, who's spoken here, said they're 93% as strong as a traditional tenon. Yes.
As far as the long piece, you don't bring the long piece to a router, you use the router, the long piece.
Yeah, you're gonna see how I took care of mortising the legs, creating the mortise. We're going to get there. Okay. So I'm still hung up on the geometry of the slot here. I haven't bored you enough yet. So this representation is showing the OD of the cutter and the ID of the guide bushing here, and so that you can see as you move around in the slot the position there. Again, you're less likely to make mistakes if you think about this. And I'm getting ready to show you one of my jigs to accomplish this. And this slot at the top is the one I used for this particular project. And you're going to ask, well, why do I have all these other holes on there? Well, I don't remember all their history, but some of them might have been for other projects. Some of them might have been screw-ups for other projects, because you've got, like this guy here looks to me like it's about the same length as that. So I probably, in one case, put this in the middle, and that was wrong, or put it offset, and it should have been in the middle. After a while, you lose track of all your mistakes, or at least I do. So I used, in this case, melamine with an MDF core, 1/4 inch thick. So if you buy the traditional Porter cable guide bushings, they're too long. They're thicker, they're longer than the 1/4 inch stock, so you're going to have to cut them off. And I do such a poor job of cutting them off that they look kind of crappy, frankly. And so I actually bought guide bushings that are sized to work with the 1/4 inch template stock.
Where'd you buy it?
Wood River. I'm trying to remember whose brand Wood River is. So here's a guide bushing that I used, and
Is that a brass? Is that brass?
yeah, this is
I
brass.
think the brass ones are 1/2 inches and the steel ones are variable, which are normally the Porter cable.
Well, the Porter cable ones that I have are steel, and
Very light.
and this portion here is too long.
Yeah.
So that's what one of them I took my hacksaw to it and I cut it off. And well, the cut went off at some screwy angle, and you could make a career out of figuring out the jig you need to hold this properly so you'd get a straight cut. And it's cheaper to go out and buy those that work okay.
It might be easier to find somebody who has a metal lathe so they can chuck that piece up and then part it off.
Well, to buy these guys was a few minutes on the computer, and they arrived in a week. But so that's the jig that I used for this particular project. I'll pass this around, but I've got a slide associated with it. So again, I like to make prototypes of things, and what the prototype you see here is one leg, one stretcher, and another stretcher to make sure that my jig is okay, I'm getting the mortises in the right location, and that all this stuff works okay.
The stretcher on the right is part of the trestle.
Yes. Yes, you're right, John. So if I'm oriented properly, then yes, this is the leg here. And this is the short stretcher on the top, and then that's the longer, or the other way around. It's the other way around. Well, I saved this piece in my shop since I knew that I was going to be making this presentation, and it would have been nice to show people. Well, I had a need for a piece of poplar, and I cannibalized it. So it's gone by the wayside. So how do you get the layout of all your mortise locations? Well, I used SketchUp to help me with that. And you want to check a consistent reference location. In this case, I measured everything off the bottom of the leg, I believe. No, maybe not. Maybe that's the top, because I see, yeah, I can't remember for sure. Anyway, pick one end of the other of the leg and do everything referenced off of that. Yes?
So did the size of the rubble that you were using influence the gap between the part that you took out of the tenon?
Did the draw bolt size impact that? Yes. Yes, it did. In fact, one of the nice things about SketchUp is that you can draw all this up and you can see what happens whenever you've got tenons and draw bolt holes, and actually the draw bolt hole ended up going through one of the tenons. I think I've got a slide in there on that. No, the question was, if you put the draw bolt hole, I guess you'd say, in between these two, and you clamp it together, is that going to weaken things if the floating tenons are too long? Was that your question?
No, just the fact that you've taken wood out.
Oh, okay. Yes, structurally, that's a possibility. I don't claim that this is the perfect design, but that's certainly a consideration that you need to worry about.
I just wondered, did you consider the size of your draw bolt in making that decision so that you would weaken the joint minimally?
I think I picked the draw bolt size to be the same as what I had on my existing workbench, and then tried to adjust the design to accommodate that, as opposed to, I think the draw bolts were, I believe that's a 1/2-inch bolt, and I could have gone down a smaller size, but I tried to move things around so that wouldn't be a serious detriment. But you're right, you run the risk of weakening things by improper placement of the draw bolt hole.
Do I visually comprehend that the draw bolt's actually going to go this way? Because you're doing mortise and tenon on this surface. So is the draw bolt going 90 degrees to that?
The draw bolt, the question is, where's the draw bolt? It's coming out like this.
On the same plane as the tenon?
Yes, so envision a hole here for the draw bolt.
So we're gluing in floating tendons, or not gluing? We're not gluing. Got it.
Yeah.
We're just floating.
Yes.
Okay.
Yeah, it's really alignment purposes.
Got it.
And in the vicinity of the draw bolt, they're not glued.
It's a fancy biscuit.
Yeah.
Yeah. Alan?
Are you gluing the Are these entirely floating tenons, or is the cannon, the stock for it, glued in one half of the stretcher?
Yeah, it's glued in the stretcher. It's not glued into the trestle end. So you end up with, yeah, it's not totally floating. So you look at the stretchers, and they look like traditional tenons on the end of a stretcher.
That's the key.
Yeah. Yes. Okay. The question is, what kind of tolerance do you need between the tenon and the mortise? I think I've got a slide in there. There are two schools of thought on that. The thing they teach you at Santa Fe Community College is that if you, let's say you've got a mortise in this block, and here's your tenon that you're putting in there, then their rule of thumb was you adjust things to the point in which if you put the tenon in there, not glued in, but just slide it in and grab it by the tenon, the mating member here doesn't fall off. That's the kind of friction fit you want. If you watch some of the popular woodworking programs on TV, they tell you, no, that's too tight, that you want a looser fit because of the potential for the wood to swell once you put the glue in there. So who do you believe? In my case, some of mine were probably a little on the loose side. All of them wouldn't pass the test at Santa Fe Community College. If you slid it in and grabbed it by the tenon, it would fall off. Rich?
So I haven't gone through this exercise recently. That translates to something, and Derek helped me out on this. You're trying to get right around 500th of an inch. 5,000.
Yeah. Yeah. Well, you've got the router bit diameter is fixed. So that's going to determine the mortise dimension. The only dimension you've got left to play with is the tenon. And so I think I've got slides where I talk about that. I'm maybe getting out of sequence. Let's hold off on that until I get to that slide. I used this Incra tool to help me with the layout some. That's more reliable than a tape measure. Again, you're not trying to achieve a certain accuracy. What you want is repeatability. If you use a square and you set your square at let's say 1/4 of an inch, and you want to draw this line here 1/4 of an inch from the edge, and so you put that mark on, and then you got to use your square for something else, and you set it for 2 inches, and you go do that, and you come back, and you got to do another one. You're going to set it to a 1/2 inch again. It's not going to be the same 1/2 inch measurement. And so using something like this Incra jig gives you much better repeatability.
Where can you buy those?
You can probably Amazon.
Internet.
Yeah, internet. You can buy them. Yeah, Woodworker Supply. Yes, Neil. Okay, Neil says he uses the depth gauge on his 6-inch micrometer or caliper to set his square. I just so happen to have a gauge block in my bucket. I tend to use a gauge block to do the same thing. So rather than fussing around with your square, trying to get it just right, use something that's repeatable. Steve?
Well, if it's consistency you want, what about just marking them all at the same time before you go off and do something else?
Yes, that for those of you that can plan that far ahead, it's better to mark them all at the same time. For those of us other than Steve, you don't want to rely on that. Yes. 5 minutes till break. Okay.
The Incra jig is in the book catalog, and the 6-inch which he was using runs $28.59 minus
Okay.
our discount.
All right.
It's worth it.
So go buy one at the break. Yes, Mike. Okay. Mike's comment is that he makes his tenon stock over thickness, and then whenever he gets to put them in the mortise, he will use some sandpaper and sand them so that they do fit the way he likes to have them fit. Yes. So I hear some people in the audience saying use a shoulder plane to achieve that. So there's no unique way to do most of these woodworking problems. You pick whatever technique you can do with the equipment you have at hand and the amount of patience that you have to expend on that. And since I'm retired, I have more time than I know what to do with, and I'm willing to futz around with these things. If you were trying to make a living at doing this, you would adopt a totally different approach.
Use a domino.
Yeah. But I don't know how repeatable a domino is. Is today's batch of dominoes the same as last month's batch? I don't have any experience. Maybe Derek could comment on the repeatability since I know he has a domino machine.
I love the domino. It's really expensive, but it passes the Santa Fe Community College tolerance test.
It's repeatable.
It's repeatable. The parts slide in and don't fall out. It's just about like what we're looking for.
Okay. So if you were in a production environment, then that would probably be money well spent. I'm surprised that you didn't take donuts and cookies and run. We only lost a few during the break. So that's where we ended up, and this is where we're going to start. This is a view of the top of my workbench, and you can see that I have the 4 legs here, 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 and here in their proper orientation. And if you look careful, you can see the triangle or a portion of a triangle here, top there, there, and then there and there. So that's to keep things oriented. And if you don't have some aid like that, you're going to screw it up. And you may still screw it up even if you have an aid like that. And there's my trusty trial joint. I was continuously looking at that, flipping it around, and making sure that things got laid out properly. And it, by and large, worked pretty good. Now this, I want to pass around something. This is a mortising jig. It's not the one I used for this, because if you look back at the earlier photograph, it had a white surface, and this is another one that I just got through using on a project of a table I'm making for Joe's stained glass studio. But the thing I want to point out here is that you need to set the offset between the fence here and the slot opening. And by doing the calculations correctly, you know what that dimension is. And you can rely on a mark on the ends. Let's see. Well, you can't see any of the marks there on the layout. Yeah, so you can use these layout marks to adjust the position of the jig. Well, one of the more critical things is what's the offset from this edge. And so you put the fence here, I'm calling this short piece of wood the fence, and then you want to use some means of setting the offset. And you can align it with a pencil mark, but unfortunately that's not terribly repeatable. Again, I'm not worried about absolute accuracy, I'm worried about repeatability. So that if this mortise is 7/16 off of that face, or supposed to be, then the mating mortise on the other leg needs to be the same. And so it doesn't matter if it's a 30-second over, a 30-second under, as long as you do it consistently. So you need to remember what face the mortise is being referenced off of. So what I came up with is, excuse me, using a gauge block, I can set the spacing of the fence relative to the edge here. And that's something that's extremely repeatable. It might be a little hard. I'm going to pass this around, and if you're adventuresome, I encourage you to loosen the star nuts and then realign it. And if you had it in a vise where you had two hands, where in a vise like this, you can align that literally within a couple of thousandths of an inch repeatably. And again, repeatability, not absolute accuracy. So I'll pass this around. Before I do that, there's a bunch of information on the back. And that's so that I don't forget what this mortise jig was made for. And hopefully, I even made some notes on how to do this better next time, because I'll forget next time. And you notice that on this particular jig, the slot here for the guide bushing is centered between these two slots. Well, if you got a router with a round base and it's symmetrical, that's great. Well, I'd gotten a new router for this, and it turns out the base wasn't symmetrical. So putting this in the middle didn't work. And so what I had to do was, fortunately, was remove the star nut and just put a hex nut on there, and I was able to do that. But I made one mortise, and it didn't turn out to be the right length. And I couldn't figure out. It
was running into the star nut.
Yeah, I was running into the star nut. So if you can screw it up, you will, or I will. So I'll pass this around. I have a metal detector out for somebody who tries to put this in their pocket and leave the building. Okay, so I used gauge blocks to set up the spacing on the jig. So that registers off of one of the edges of the leg. So here is a picture of the upside down router. And this is a Porta-Cable plunge router. I purchased an aftermarket base here from a guy named Pat Warner. Some of you probably have bought router books written by Pat Warner. Unfortunately, he's now deceased, and so this is no longer available. So there's a conical shaped centering guide so that you can chuck this inside, or put this inside the chuck. This little insert here goes in the opening, and you can make sure that the router is centered inside the guide bushing. If it's not centered, then you take the router and you go back and forth one time, and the next time you turn it 90 degrees and you go back and forth, and you get a different width. So you lose your consistency in that case. With this Porta-Cable router, there was no dust collection associated with it, other than you stop, you lift the router out, you take your shop vac, you suck out all the chips that have gotten compacted in there, and then you go back to work. So it really required many passes stop and start in order to get to the final depth. And then make one last cut after you got all the chips sucked out, and you go round and round in it so that all of them end up being pretty close to the same width. So one little whiz gadget that I found from Fine Woodworking Tools and Shop issue in 2016 is how do you tighten up and loosen that guide bushing? Well, I've had to resort to things like a shop rag and a pair of pliers because I couldn't get it loose. Well, use a spanner wrench and drill holes in the guide bushing so that it will mate with the spanner wrench. So here's the spanner wrench. You can see the holes. You can see the holes in the guide bushing and the spanner wrench. And here's a little, I think I may have had my hand in the way, Steve. Okay.
Water bottle that you're gonna.
Yeah. And a handy dandy jig to put this in so that you can drill the holes in the guide bushing with your drill press. Yes, Gail?
Where'd you buy your spanner wrench?
Amazon.
You can go to a bike shop. It's a standard bike tool.
Yes, that's, it's easier to go to Amazon though, Derek. Click. 2 days, it's under your front door.
I agree with you 100%.
And you don't need to buy 2 like I did. There's this size, this is a number 2, and I forget if the other one was a 1 or a 3, but I've now got one that I don't need. So buy the number 2 and then put your calipers on here and see what drill bit size you need. So I'll pass this around, and you'll notice that there's a flat on the guide bushing here. That's because when you drop brass, it doesn't bounce very well. It goes...
Well, it's an experiment.
Yeah, it goes splat. So this guy's dead, but I'll pass this around with the spanner wrench, and that really works. And so I just happened to find that in Fine Woodworking. So here I'm finally going to get around to making a mortise. So you safety guys, Mr. Sherrard, what am I doing wrong here in this setup? What's going to happen here if I'm not careful? This clamping mechanism here is, unless you really get your cheater bar out and clamp on that vise, it's going to sag down. And I actually had one that dropped just a little bit, and I had a oh you know what moment. And fortunately there were no bad consequences of that. And so here's a better way. Yes, I did tighten it, but it wasn't tight enough given this size router and that lever arm. And so I put a clamp across there so that this end can't lift up now. I've actually done a similar setup on a second table that I just finished, in which the length of this board was about 6 feet, and I actually had to clamp a vertical arm out on the end here to make sure it didn't sag. So that's the basic setup for doing the routing. I've already passed around the tenon stock. So this is where this piece came from. One little piece of information, you learn that when you're trying to get the thickness of the tenon stock just right, it doesn't fit in the hole. And so you run it through the planer, and well, you've got an opening and you put a corner in there, and that doesn't work. So take a narrow piece of tenoning stock, and that's what this represents here, and use that to set your surface planer to give you the desired thickness. So you can see here that it's much, it's shorter. There's no round over on that.
So you're using that as your sample?
Yes, that's the sample. You need a sample anyway, and so just use a sample that is narrower than the desired tenon width. So once you get tenon in one of the stretchers, there's a tenon right in there and another one down there. You want to put them in, but you don't want to either get your biggest hammer around and hammer them in and mess up the end of the tenon, or drive them in too far, because you make your tenons, they should be about 1/16 of an inch shorter than the mortise. Or if you look at it from the other perspective, the mortise should be a little bit 1/16 of an inch deeper than the tenon that you want. So this is the jig that I made to set the depth that the tenon goes into the mating mortise. And here's a better view of that. It's just a U-shaped channel, and so you're assured then that whenever you pull the clamps in, and that this face is up against the mating face of the stretcher, the depth of the tenon is set carefully. You can put a mark on the outside of this, and then you're tapping with your hammer, and by then the glue seizes up and you get a bigger hammer, and by then you've boogered up the end of the tenon, and then you're frustrated and not a very nice person to be around.
You start all over.
Yeah, you start all over. But another thing I learned, not from this, but a follow-on project, is there has to be some slop in here so that this U-shaped channel slides easily over that. I made a mistake in having a little bit of a friction fit, and so when I drove the tenon in, it was deeper than it should be. And I couldn't figure out why, and finally the light bulb went off that bad idea. So here is the setup I used to drill the draw bolt holes. So this is one of the legs that was drilled on the drill press. So there's no problem with drilling a through hole here and getting it perpendicular and all that good stuff. That's an easy thing to do. So you can see the stretcher, the end of the stretcher in the vise there. And so you end up using the leg as a guide bushing, or a drill guide essentially, to drill the hole, transfer that hole into the mating stretcher. So by this point you've got tenons in place here, and you pull them. This setup ensures that you drilled as deep as the drill will go in the stretcher, and you have it perpendicular to that face. Well, unless you've got really long drill bits, it doesn't quite go deep enough, so what you then do is you remove the leg out of the way and then just freehand drill it the rest of the way. And that seemed to work okay. That's what was used on the sample that I passed around. So this is the first time I dry clamped everything together. And there's more than one reason for doing the dry clamping. One is to see if it's going to fit together. And then two, once you dry clamp it together, this was the actual setup that I used to finish or to get the right depth on the stretcher for the draw bore hole. So it was actually held together by the clamps, and I just freehand drilled the draw bore holes the rest of the way. And it was literally heart and throat time, because if you've not done this before, you don't have confidence in the outcome of this, and fortunately it seemed to work out okay, and it was stiff enough. So here's the rather crude setup for gluing up the two tabletop layers of melamine over MDF.
Why did you glue them together?
Because if you don't, when they're going to separate over time.
You could screw it from the bottom.
Could.
Because then you can change it. Change one, you change the top one and throw it away, and the bottom would still be there.
Another way to do it.
I guess it
wasn't your project.
I'm being esteemed now, aren't
You forgot to tell them when you were talking about it.
Okay, so obviously my clamps don't reach out to the middle, so I had to use some concrete blocks and some concrete pavers that I had around.
Those through Amazon?
Brian? No, I didn't get them through Amazon, John. Brian?
What kind of glue is Rue glue? I've never used it.
Okay, Rue glue is something that's used to attach things to melamine. And with the name Rue glue, I believe it's Australian in origin, as in kangaroo. And you can buy it at Woodworkers, I believe. If you can't, you can get it on Amazon. So it's buy it in a quart bottle, or no, it's not even a quart bottle, and it's kind of a milky white color, but it's designed to work on melamine, gluing wood to melamine.
Is it better than the typical contact cement that you use for melamine surface?
I don't know that it's any better or any worse. I was introduced to this at Santa Fe Community College. They said that that's what they used. We made covers for our workbenches out of 1/4-inch melamine, and put a wooden border around part of that, and that's what they said do, is use Rue glue to glue wood to melamine. John?
You abrade the melamine surface.
No, I didn't do that.
What was the question?
The question was, do you abrade the melamine before you apply the Rue glue? And I did not, and the indications are that that's not a necessary step.
Do I recall that there are sheets of melamine that come with different thicknesses of melamine?
Yes.
Probably so.
Melamine.
My guess is, the question was, can you get melamine sheets that have a different thickness of the melamine itself? And I'm just speculating, but I think you probably can. Gail is saying yes. So for the big box stores and the typical homeowner, they don't care what it is. But in the, say, the industrial woodworking where you're making furniture with melamine surfaces, you probably can get a higher quality. But whether you and I can order it from Amazon, I don't know, John.
Well, then I don't need it.
Yeah. If you can't get it from Amazon, you really didn't need
you
it.
didn't need it. No way. I'm not going.
Yeah. Okay, there's a familiar face. Mr. Sherrard volunteered to come over with his trusty jig here and cut the 2 slots in the tabletop to match the miter gauge slots. And so I appreciated his help muchly on that. And just like in Navajo weaving, you got to have a flaw somewhere.
Yeah.
Well, I made one screw up on the mortise. That's all. I don't know how many, I forget how many I made, but this was one that, oh, it doesn't belong there. So I don't even remember why, so I took some of this tenon stock and pounded it in there and cut it off and sanded it and kept on trucking. Yeah, that's a design feature. So there's the pristine finished product.
How do you fasten the table to the saw?
Okay, I don't have any slides that go into that, but with the back side of the saw stop, there's an L-shaped channel or a rail, and so there are bolts that go in from the underneath side of this L-shaped rail that rigidly attach the tabletop, or the outfeed table to the saw.
Did you use bolts or lag screws?
Trying to remember.
I use lag screws.
It seems like I used both, but I'm not sure now that I think about it.
Where are the heads?
Well, I could have put a strip underneath there that I glued on there and it stuck out, and then there's a bolt through that ties it on. I'll have to go back and look. It's been a while since I finished this, so that's...
How
Yeah.
much do you think that table weighs? Because it's big.
I don't know, 150 pounds, maybe, something in that range. Linda?
Can you tell me what about the saw stuff? Can you tell me what model it is?
The saw stop, what model is that, was the question.
The professional.
It's the...
Horsepower 3. It's a 3 horsepower professional.
It's not the industrial, it's one step down below the industrial
So
grade.
it's above the
Yeah.
bottom.
Yeah, it's step above the contractor saw that they sell. So it's...
This is a specific question directed to you because I'd like, out of curiosity, to know how much time you spent, best of your knowledge, to designing this through SketchUp versus building it.
I don't have a good feel for that, John. I get a certain amount of satisfaction out of just playing with SketchUp. And so I don't count that as part of the yeah. Yes, Bill.
Is that instead of watch TV?
Maybe I missed it, but how did you attach the tabletop to the legs?
The tabletop to the legs. I don't think I've got a slide for that. That was screwed to the rails from the underneath side, I believe was what I did.
No, it wouldn't be pocket. You'd just be screwing straight up.
Okay. So I shared this with Steve in the break, and I'm going to sort of tell off on myself. Whenever I got to this stage, probably before Mike helped me with the slots, I got it together, and I was convinced that it was going to be strong enough. You don't see it in the picture here, but there is one shelf. I actually crawled up inside the table, the outfeed table, and lay on my back and just bask in my glory for at least 30 minutes. I had nobody out there bother me, nobody to say, "What the hell are you doing down there?" I just lay there and looked at my handiwork. So, in summary, There's a lot to be said for building prototypes of joinery, especially when you're not professional at this. You haven't done 10s or 20 or 100 of these things. I've been extremely pleased with the finished product. It gets a lot of use, probably more use as a work surface than an outfeed table. I gained a lot more experience with the floating tenon joinery, and with the tools that I have, I think that's the way to go. I've cut traditional tenons on table saw and worried about square shoulders like I think Steve mentioned. And, I believe this is a faster way to do it with the tools that I have at hand. And then the very last slide. There it is at work. Full of junk.
It's okay. Sure.
It's not big enough. You got stuff on your table.
I know. Yeah, I should have made a bigger outfeed table so I wouldn't have to clutter up the saw here.
Oh, you'd still clutter up the saw.
If I look in this photograph here, I can see 2 screw heads. And so now that I think about it, I'm pretty sure I screwed down from the top and countersunk the holes. Mike?
Is that where you attach the cable to the main saw?
Yes. I think it is.
Did you make that post?
No, that came with this space. No, that's not something that an engineer would do, John. It's much too artistic. Jim?
Ben, your guide bushing and your spanner wrenches came through, and I admired the heck out of that. But I'm not going to ask for a show of hands that use my system. My system is called channel locks and shop rag.
Well, the shop rag and channel locks are the preliminary version of what I passed around. I've used that same version, Jim, and I saw this and I really like this a little bit better. But be careful with brass and don't drop them. Yes, in the back. Okay, where would you look for something like that? Okay, the suggestion was look in Granger and you can see an alternate to this style of guide bushing. People that have been doing other things similar to woodworking for years have got a lot of neat tools out there. Us woodworkers don't oftentimes look at the right place for them. And so that's one of the benefits of these meetings is you get somebody who says, well, why didn't you do it like this? That's a lot easier. L-E-I-G-H.
Oh, the J. L-E-I-G-H. It's a Canadian company.
Okay, Tracy's saying if you look at Lee, the people that make jigs.
My memory's about as good as yours, so there could be some. This could be wrong. I'm pretty sure that's where I got it.
Okay, so you heard the caveat that this may or may not be accurate information, but check the Lee catalog who makes jigs for other guide bushing approaches. Gossip or gossip? Gossip. Okay. So if it doesn't work, it's gossip.
Did you not take advantage of all the space under the table?
Not yet. Not yet. I've seen. I saved a fine woodworking article that shows essentially how to put cabinets essentially in an opening like that. And I haven't decided where I'm going to go. It's just a shelf now.
Santa Fe Community College, on all of their workbenches, their bottom, they have a bottom shelf, but they don't have any cabinets in it at all. And that's where you put the wood that you're using for a project. And it's really a handy way to save stuff.
Yeah.
Very, very, very smart idea. And it takes nothing to build nothing.
Steve?
Ben, can you say a little bit more about the process for cutting those slot extensions and whether you do that with the table in place against the table saw, or you just mark out for it and then move the table back and then cut it?
What's the question?
The question was cutting the slots in the table for the miter.
Yes.
Going back to the one with Sherrard in it, unfortunately.
Okay. I believe we extended the slot lines with a pencil mark out onto the table. Then we separated the two units so that you could get at the work a lot easier. And also, there's a screw where we screwed into the stretchers on that. So, and Mike's jig there, you have anything you want to say about your jig, Mike, for doing this?
Real simple to make. I made that when I was at AWA2018, so that you could trim the two edges of AWA2018 and have them put together and have them made exact. That's a straight edge on there, and it's just 1/4 inch hardboard, and you can make it as long as 8 feet because that's how long hardboard comes. And the longer you make it, the more accurate it becomes. But we found out that about 14 inches was great work to. How's it work? There's a strap edge guy, and you'll see that there's a steel straight edge sitting on that table. You draw your lines first, so you know exactly where you want them to get the straight edge, and put the router on. You don't run the router. You double check where the blade is with the lock at both ends, and when it exactly lines up, then you can go ahead for it.
So this attaches to the base of the router.
Right, well, that is the base of the router.
Yeah.
The base off with that.
Okay. We actually pull the base off the router.
There's one pass.
Um,
It's not that deep.
Yeah. Okay. More questions?
Is the width of those slots exactly the same as on the table saw, or is
No.
it a bit bigger?
They're more than a little bit bigger, because if this edge here was not perpendicular or parallel to the edge of the saw, then you're going to be going off at slightly an angle. It'll work okay here, but it won't work when you get down that far. So all you're trying to do is have a slot for the
Just create clearance.
yeah, it's clearance.
Right.
So it doesn't matter as long as it's wide enough is the only criteria. Yes. Yeah, your miter gauge or sled is still guided by the table saw and not these slots here.
Well, those slots can be oversized because by the time your slide gets out there, your work is already through the blade.
That's right. Yeah. Okay, more questions? Thank you for your time and patience.